Welcome back. In the previous sessions, we have seen the design of finite state machine as a divisibility tester. We had designed finite state machine for various number systems such as decimal number system, binary number system, and ternary number system. In case you have missed out on any of those session videos, you can just click on the I icon over the top right corner and visit those videos. In this video, we will be seeing the design of finite state machine as a string validator. The first string that we will validate is ends in 100 and second string that we will validate is ends in BABB. So let's begin. Design finite state machine in which the input is valid if it ends in 100 over the input 0, 1. Solution. Step number 1 as usual is theory, that is the definition of FSM. Step number 2 is logic. Now here, since input is already given, I will be equal to 0 and 1. O will be Y and N again, as we are just simply validating the input string whether it ends in 100 or not. So where the machine will give us the output as either S or no, that is Y or N. And our S will be equal to Qs, Q0 representing 0, Q1 representing 1, Q2 representing 1, 0 and Q3 representing 1, 0, 0. Step number 3 is implementation. So as we can see that our S, that is states, Qs is a start or initial state represented with the arrow, Q0 0, Q1 will represent 1, Q2 will represent 1 0 and Q3, which is our final state, will represent 1 0 0. Now as we all know that our FSM or the finite state machine will take one input at a time, and we have to transit from first is input symbol to the end of our input string. So here we will scan our input one bit at a time. These bracket values are for our understanding, and machine will be concerned only with the transitions that we will be mentioning in our transition table. So here Q0 representing 0 is nothing but for our understanding how this transition table should work, or the altering of the states should work. So let's begin. When we are in QS state, the first symbol if I am getting is 0, I should move to Q0 state. If I get 1, I should move to Q1 state. Now when I have reached Q0 state, and my previous bit that was scanned by my machine was 0, and the next input that I am receiving is 0, then it becomes 0 0. But since we do not have any state representing 0 0, we will stay in the same state. And my previous machine scanned input was 0, and the next input I am receiving is 1, it becomes 0 1. Again there is no state representing 0 1, so I will transit to Q1 state, which is representing 1, as it becomes ends in 1, that is 0 1. When I am reaching Q1 state, the previously scanned input was 1. Next input I am getting is a 0, creating 1 0 as the string. So we have a state representing 1 0. So we will transit to Q2 state. And 1 1, there is no state representing 1 1. So we will stay in the same state, that is Q1 state. Now once I have reached Q2 state, that means I had previously scanned 1 0 as the input. Okay. Now next input I am getting is a 0 or a 1. Okay, so here it becomes 1 0 0. So I will transit to Q3 state, and 1 0 1 becomes ends in 1. So I transit to Q1 state. And finally, when I reach Q3 state, that means I had scanned 1 0 0 completely, and next input I'm getting is a 0. Now from Q3 state, if I have to transit back somewhere, that means my string has not, input string has not ended, and there is still some symbols remaining to be scanned by the machine. We have to go back and trace 1 0 0 again till we have reached the end of our string. So from here we will transit to Q0 and Q1 states respectively. Now since wherever there is Q3 present, we will be marking it as Y because Q3 is our final state for this FSM. So rest other than Q3 state will have N as the output, that is no, and wherever there is Q3 present in the state transition table, that is STF, we will mark it as Y. Part 3 of our step 3, that is implementation state transition diagram. Now when we are in QS state, we had found that on getting 0 we have to go to Q0 state, and on getting 1 we have to travel to Q1 state. When we reach Q0 state, if I am getting zeros till it gets 1 as the next input symbol, it will stay in the same state. As soon as it gets 1 as the next input symbol, it will alter and go to Q1 state. In Q1 state, it will stay in the same state unless and until it gets the next input symbol as 0. After reaching Q2 state, on getting a 0, it will go to Q3 state, or else if it gets a 1, it will go back to Q1 state. So as you can observe here, the string 1, 0 and 0 is getting formed in our state transition diagram. Now here from each state, it will have two outgoing transitions on each inputs representing each input symbol, that is 0 and 1. Let's solve an example. QS 10100, as we can see or observe that it is ending in 100, it should give us the output yes. So from QS, on getting 1, I will go to Q1 state. Next, on getting 0, as we can see in the state transition diagram, on 0 we have to reach Q2 state. Now from Q2 on getting a 1, I will reach Q1 state. From Q1, 0, Q2, from Q2 on 0, Q3, and giving the output Y. Another example, as we can see, it is not ending in 100, so it should give us the output no. So Q1, Q2, Q1, Q2, and finally Q1, and output will be no. So as we can see from QS, once it has traversed to Q1 state, it is alternating between Q1 and Q2 state. In case if it would have found a 0 after 1 0, we would have reached our final state of Q3. Let's solve one more question. Define or design finite state machine in which the input is valid if it ends in BABB over the input A, B. So the solution goes as step number 1 theory, that is the definition of FSM. Step number 2 is logic. As input is already given, our I is defined, that is A, B, set of A, B. O again is yes and no because in the question it says input is valid if it ends in BABB. Next, S will be A represented by Q0, B, then we have BA, BAB and BABB. So there are QS, Q0, Q1, Q2, Q3 and Q4 states representing all these types of strings or substrings that can be scanned by our FSM to reach the state which will declare that this given input string has ended in BABB. Let us design our state transition function, that is STF. As we can see the states QS to Q4, here Q4 will be marked as final state and QS is marked as our initial or start state. Now again I'll repeat, the things written in the bracket is just for our understanding and it is nowhere concerned with the inputs or the strings that will be given as input to our machine. Your A, B, BA, BAB, BABB represent that we are just concerned with the substring BABB and nothing else should be scanned, or the machine should not give any validations for other strings other than BABB. So when we are in QS state, on getting A and B, we will go to Q0 and Q1 state respectively. Again from Q0, we will go to Q0 and Q1 states itself. After reaching Q1 state, the previously scanned string was B. Next input if I get is a A, it becomes BA, which is represented by Q2 state, and on getting a B, I will stay in same state, that is Q1 state. After reaching Q2 state, next input symbol I am getting is a A. We do not have BAA as a state represented anywhere. So we will check that we have a state called as Q0 representing ends in A. So we will go to Q0 state, and from Q2 on getting a B, we will reach Q3 state. Next, when we reach Q3 state, next input symbol that I am getting is a A. Now here we will reach Q2 state. Why Q2 state? Because the string that will get formed is BABB, BABA. So here again it becomes ends in BA. In case we had any state representing BA, we would have reached that particular state. But since there is a state representing ends in BA, we will reach Q2 state, which is BA. If we wouldn't have had BA as a state, we would have reached Q0 state, that is represented by Q0. A represented by Q0 state. And finally, when we reach Q4 state, we will go to Q2 and Q1 states respectively, as again BABB, and after getting the next symbol as A, it will become ends in BA. So we have to reach Q2 state, and for Q1 it will go because it is B, because we do not have any state representing BB or triple B or so on. Now designing the MAF, that is the output machine function, we have again Q4 only Y, and rest non Q4 or non-final states will be no, that is it is not a valid string. Now the final step or the final stage of our step 3, that is the state transition diagram. We have QS to Q4 states, where Q4 is our final state and QS is our start state. We will transit according to the state transition function that we have defined. Now for the solution of step 4, that is example QS ABB ABB. So here as we can see that our string is clearly ending in BABB. So it means that it should reach Q4 state and give the output as yes. So let's see this transition, how it is transitioning from QS to Q0, Q0 to Q1, Q1 to Q1, then Q1 to Q2, Q2 to Q3, and finally Q3 to Q4 to give the output Y. Let us take another example and get a clearer picture about how it will give output as no. So from QS to Q0, Q0 to Q1, Q1 to Q1, and finally Q2, giving the output as no. I hope today's session or this video was much more better in understanding. In case you have any queries, you can leave your questions in the comment section and we can resolve it in the next session when we have.